St. Claret College, situated in North Bangalore of Karnataka state in India, aims to create an informative and sensitive future citizens through Claretian mission of education.
At St. Claret College, the focus of our education is to form individuals of character and integrity. Individuals who would become agents of social change and transformation. And for that to happen, we will certainly provide our students well-rounded education.
Situated on a serene and picturesque campus in the Garden City, Bangalore, we provide world-class state-of-art infrastructure and facilities to our students.
Our graduates become critical thinkers. Our graduate becomes individuals who are really very creative. And that happens when we provide them with an engaging curriculum. A curriculum that certainly responds to the needs of the industry, responding to the needs of the times.
Claret Group of Institutions caters to a large number of students, more than 9,000 in its campus, enabling them to understand and learn together to become thought leaders.
We believe in education that is inclusive and socially just. So Claret College has been offering education at an affordable cost to help and support everyone's aspirations.
Holistic growth of students is the core of our educational mission.
The education that we offer is faith-based Catholic education. And at the same time, we know the term Catholic literally means universal. And our education is inclusive. Our classrooms certainly represent the diversity of culture, diversity of languages, diversity of belief systems that India represents. And we offer our students the best so that they become global citizens.
Welcome to Claret College, the abode of knowledge. Claret College, situated in North Bangalore of Karnataka state in India, aims to create an informative and sensitive future citizens through Claretian mission of education.
At St. Claret College, the focus of our education is to form individuals of character and integrity. Individuals who would become agents of social change and transformation. And for that to happen, we will certainly provide our students well-rounded education.
Situated on a serene and picturesque campus in the Garden City, Bangalore, we provide world-class state-of-art infrastructure and facilities to our students.
Our graduates become critical thinkers. Our graduate becomes individuals who are really very creative. And that happens when we provide them with an engaging curriculum. A curriculum that certainly responds to the needs of the industry, responding to the needs of the times.
Claret Group of Institutions caters to a large number of students, more than 9,000 in its campus, enabling them to understand and learn together to become thought leaders.
We believe in education that is inclusive and socially just. So Claret College has been offering education at an affordable cost to help and support everyone's aspirations.
Holistic growth of students is the core of our educational mission.
The education that we offer is faith-based Catholic education. And at the same time, we know the term Catholic literally means universal.
Good morning. Good morning to people in the US and good evening to everybody in India. Yeah, good evening and good morning to everybody. We'll start now. I'm very happy to have Sydney Rechten with us today. Sydney is CEO and co-founder of the Creators Attaché and also a good friend of mine. She is going to tell her story of her career pursuit. And the reason I'm looking forward to listen to her is because she has an incredible journey. It's absolutely fearless, and that's why she's talking about how to fearlessly pursue your career. To give a little bit of background for her, she was in manufacturing industry. She was focused on statistical process monitoring, and then she felt the need to learn more statistical details, and so she joined the data analytics master's program at Georgia Tech. Thereafter, she continued to apply advanced data science and modeling in manufacturing, and then decided to change her career track to move to something completely different and found a creative company. She is extremely passionate about everything that she does, and that's why I believe she can do everything so fearlessly and succeed in everything she does. I look forward to listening to her. Sydney, I will hand it over to you.
Awesome. Thanks, Cheetah. Thanks for such a warm welcome here. I'm going to share my screen. At least I think I am. Can you see my screen?
Something is coming, but it's not perhaps the screen.
Okay, give me a second. Okay, let's try this. What are you seeing now?
Yes.
Okay, so you see half of a video of me and half of a presentation.
Yes.
Perfect. Okay, cool. Well, I won't give too much more explanation about who I am. Cheetah just gave a great intro to sort of my corporate career and where I'm at now. My name is Sydney Rechten. People call me Sid. I am the founder and CEO of the Creators Attaché, which is a business that I started in 2019. And we do digital business operations for small businesses. So we build, design, and manage digital infrastructure for small businesses who otherwise would be doing things on their own. When you start a business, you tend to take on many hats. So we provide our clients with that digital infrastructure and a strategic marketing team. So we have a really creative side of our business, which we'll definitely talk a little bit about today. And then we also have a systems branch, which grew out of me saying yes, which we'll also talk about here in a bit. So if you, hang on, let me click, here we go. So 2 years ago, you could have caught me jet setting around the world, giving talks in Italy and in Germany and Finland and all of these wonderful places about a platform that Cheetah and I worked together on, basically building advanced manufacturing algorithms and a platform for basically for advanced manufacturing. And it was really cool and really exciting and left me severely unfulfilled. And that is all about, we're going to talk a little bit about like lack of fulfillment here, but since then, since 2 years ago, I would say that most people would have considered me having this amazing career, well paid, great career path forward, great visibility to senior management across very large corporations in my industry, pretty much the dream of a college student walking into a career that was basically helping them climb the ladder while creating incredible innovations along the way. But since then, as Cheetah mentioned, I've pivoted, started my own business, tripled my income. And I think there's one characteristic behind my path from the moment I started taking internships in college all the way through now that sort of sets me apart from my peers. And it's not something that's hard to achieve, and that's fearlessness. I really do believe that being fearless is what's helped me land my now dream career and continue to develop and grow my dream career. And I really want to share with you guys what it means to be fearless and how to start walking that path of being a fearless leader for yourself. I really think that when people start talking about fearlessness, they mix it up with confidence. And I think that a lot of people are confident, and I think confidence is good. And think about it. Some of you in the room might be saying, oh, I'm really not confident. And confidence looks like knowing something well, right? Like you're confident that you can tie your shoe. You're confident that you can do your homework assignment because you just paid attention during lecture. But confidence sometimes holds you back when it's by itself. So think about the time that you're sitting in a classroom or in a meeting or working on a project and you know the answer, but you don't say anything. Or maybe you don't know the answer, but you know for a fact that the person who thought they knew the answer is wrong, and you still don't speak up. That is confidence in what you know, but a lack of fearlessness in taking action. I truly believe that fearlessness implies that you take action. And there's another side to confidence too, that's not so great. It has this negative connotation. And sometimes that is when confidence is combined with a lack of humility. In short, some people call that being egotistical. I think that confidence and humility and action together go hand in hand to create fearlessness. And developing fearlessness isn't really difficult. Truly, it's not. Today, I'm going to tell you the ways you can develop fearlessness, that you can pursue your career in that way. Before we get into the crux of the conversation, I want to make one more point about confidence and fearlessness. And that's that I think people, in fact, I know this for a fact, if you were to ask 10 of the last people I worked with in corporate America, even my current clients, I think that most all of them, 8 out of 10, would probably describe me as confident. And I am. I certainly am confident. You don't have to be both confident. You don't have to be confident to be fearless, but confidence and fearlessness together are really a dynamic duo. You can have fearlessness though and pursue your career with this level of knowing that you can and will achieve whatever it is that you're going after. And I think that the thing that makes you a fearless leader of your life and of your career is twofold. It's your mindset and it's the habits you cultivate. Those things together allow you to take action in the pursuit of your career. So if there's 2 things I really want you to take away from this call, it's what areas of your mindset that I'm about to talk about that you could really improve upon. And I'm going to give you some tactical tools of what I do to exercise my mind every day. And then also, what habits can you start forming around the general areas that I'm going to talk to you about so that you can start showing up with that fearless mindset and taking action in pursuit of your career. So we're just going to dive right in. What does it mean to have a fearless mindset? Of course, all of this is from my own lens, right? This is from my own experiences of stepping forward in my life and especially in my career with fearlessness. And when I look to who I look up to, what other fearless people are in my life, there are 3 things that we all have in common. The first one is that we choose to believe that the realities of the world don't define our reality. Okay, that means that whatever's going on the outside of the world doesn't have to impact my life unless I want it to, unless I allow it to. And that kind of folds right into the second thing that fearless people have in common. We understand that we control how we view the world. We understand that there is a world out there that has a lot going on and that we get to put our own perspective on that world and respect others' perspectives of the world as well. And last and probably most importantly, people who are fearless in pursuit of their career know that at the end of the day, it's simply their responsibility to take action. No one is going to do it for you. In fact, I remember as a child, my dad telling me, no one is going to look after you as much as you. I might have been 10 or 12 at the time. And I just remember thinking, well, gosh, my parents are supposed to take care of me, right? But what he meant was no one knows exactly what's going on in your brain. No one is going to know exactly what action to take in the moment. No one is going to vocalize your needs, your wants, your desires, the things that are causing you pain, anxiety, frustration. No one can vocalize those or do something about them except for you. So at the end of the day, fearless people know that it's their responsibility to take the action. And I think there's something really important that everyone can do daily to harness this fearless mindset. Some of you guys may be thinking, I am definitely not fearless. I do not speak up in class. I do not speak up in my friend group sometimes even, or maybe in the past you've spoken up and you've faced some turmoil or you've had some issues with that. And me too, right? When you decide to be fearless and take action, you're deciding to accept failures along the way, right? You're going to learn from those failures, but you're making the decision of, okay, I'm going to step forward and take action towards what I want fearlessly. You know, you're going to combat things at every angle on the regular, which is why I do this exercise every single day. I really, really want you to write this down. If you have pen and paper, I'm old school. I do everything tech all day long, so I love a pen and paper. If you're not old school, grab your iPhone, open up the Notes app, and I want you to write these 3 things down. I write this every single day. The first is, I am at cause for my life. What does that mean? Most people live in effect of their life. Stuff happens to them in the world around them, and they just accept it as their reality. Oh, there's a lot of traffic out today, so I'm going to be late, which means I'm going to have a bad day. Oh, someone hurt my feelings, and now I have to deal with trying to mend this relationship, and oh, we're never going to get through this, right? So a lot of people live in effect of their life. Oh, I made a bad grade, I'm going to fail this class. Fearless people live at cause for their life. So they don't let the effect of the world around them become a reality in their life. They don't let bad weather dictate whether or not they go on a run, for example. Okay. The second is, I get to control how I respond to everything. I get to do that. I get to decide that if someone hurts my feelings, how long my feelings stay hurt has nothing to do with their apology. Someone who's wronged me in the past has nothing to do with their apology. I get to decide how I respond to that situation. And kind of a fun fact, I don't know if you can tell by my movement on camera, but I'm a fairly feeling person. I have a lot of emotions, as my husband would say. In fact, in our vows, he said, "You are very passionate." That is how he described it, which was very kind of him. But I go from high to low really easily. I enjoy feeling emotions. A fun fact about emotions is typically they're backed by a chemical response. And big emotions that feel overwhelming, fear, anxiety, stress, hurt, chemically, they only last 90 seconds in your body. So after you feel the feels, you get that rush of anxiety, or someone just pulled out in front of you on the road, so you slam on your brakes, that rush you feel, that's gone in 90 seconds. After 90 seconds, your mind is now choosing how you respond to that event. So fearless people understand that they get to control how they respond to things in their life. And the last and likely most important one, like I mentioned on the last slide, this is what I write down. I get to take 100% radical responsibility for my life. I get to do that. I don't have to take responsibility for my life. I don't have to take radical responsibility for my life, meaning I will look outside of the box. I will do whatever I have to do, whatever I want to do, whatever I can do to pursue whatever it is that I'm pursuing in my life. I don't have to do that, but I get to. And when you realize that that's a choice that you make, that really settles in this fearless mindset. So write these down, write them down every day. It takes me 3 seconds. I have them memorized. Every day, one of them will sit with me a little bit more than the other, right? So if I have a lot on my to-do list, I get to take 100% radical responsibility of my life. That does it. If the trash wasn't taken out because my husband cannot, for the life of him, listen to simple commands of his wife, I would think about, I get to control how I respond to everything, right? So write these down. But having a fearless mindset isn't the whole thing. You can have this mindset kind of in secret, right? You have to ultimately take action with that mindset in order to fearlessly pursue your career and your life and really anything you want. In order to do that, you'll have to develop habits that complement that fearlessness. And I really wish I could tell you that there are 10 habits that I've cultivated that have allowed me to go from being a senior in college, applying to a bunch of jobs, figuring out what offers I do and don't want, negotiating things left and right, to getting into a career, navigating promotions, navigating unhappiness, navigating hard conversations with my boss or my boss's boss or my boss's boss's boss, which is a long story. But there's not 10 habits to share with you because they're unique to me. I do, however, think that people who are fearless have 4 categories of habits. And I loved watching the little intro video today. It was just a nice reminder that boundaries are so important. 2 of the categories of habits that I want to share with you are about 2 different kinds of boundaries. The first one in creating fearless habits is setting personal boundaries and communicating them. Having a personal boundary and telling no one about it is a useless waste of your time. It typically leaves you feeling like people don't care about you, or people don't, they don't understand what you want. If you don't tell them, they're not going to know. So personal boundaries that fearless people set and communicate are about their time. What time are you willing to give to other people? What time are you willing to set aside for yourself? Your time is a boundary that you have to figure out who you're going to give your time to. What amount of your time are you going to give to work? What's your work-life balance like? I just went through a season in my business where my choice for work-life balance was to have no balance. I was growing a business and I chose to put in 80 hours a week into my business. I chose to wake up, eat, work, eat, sleep, work every single day. And by making that choice, by taking radical responsibility for that choice, I was able to grow parts of my business. Now, a year later, I'm in a different place. Now I'm focusing more on life. So you have to figure out what work-life balance you want and go after that. Probably the most important thing for this group of people as far as setting personal boundaries as you go and make strides in your career, but not only as you start, as you stay in your career, is learning how to set boundaries for your salary and benefit negotiations and communicate those. You see, when you are feeling valued by your employer, you're going to do better work. It's a win-win situation. Now that I run a business, I understand this more than ever. I just want my employees to tell me exactly what they want so that I can figure out how to meet them as close to there as I can. As a business owner, you and as a boss, you want your employees to feel valued because you know that they do better work. So sit down with yourself and ask yourself, what salary do I want? How much vacation do I want? How am I being realistic? What are my experiences? What does the market tell me, right? Have that number, have those benefits in your head and communicate them when you're hunting for a new job, when you're seeking a promotion, whatever it may be. The second is what data scientists are here for, finding technical boundaries and then pushing them. If you don't know where the technical boundaries are, you can't push them. If you don't seek them, you won't find them. Finding technical boundaries is about innovation. This is why you're hired as a data scientist. Most likely, if you're in this field of AI, data science, market research around it, your job is going to be to innovate because it's still so new in so many industries. Finding technical boundaries and pushing them is about change. And in fact, kind of a sub-habit underneath this habit is to run from anyone and anything who resists change. My biggest ailment in my corporate America career was that I constantly was working for companies who didn't appreciate change. Why? Because they're the ones who paid me the most money. I think that they knew inherently that they needed change, and so they wanted a change maker, but their culture was not set up for change, which left me, a change maker, feeling very unfulfilled. So ask companies about their change culture. That word right there, when they ask you at the end of the interview, do you have any questions for me? Yes. What is your change culture? What is your change culture at the boots on the ground level, the lowest man on the totem pole? And what's your change culture at the senior executive level? If both of those layers of culture aren't willing and able to create and cultivate and make and experience and feel and work towards change, if you're a change maker and if you're a fearless in pursuit of your career and you're trying to find technical boundaries and push them, you're going to be unfulfilled. One of the most fun habits is saying yes and then doing research. We're going to talk a little bit more about this. I know I mentioned that earlier already, but my whole business is built on just saying yes. People who are fearless in pursuit of anything in their life have an intuition and they listen to it. Your gut tells you, oh, I don't know how to do that, but I know how to do this other thing that's kind of similar. And I think that I could probably YouTube 700 videos and figure out how to do this other thing. Or I think I know this network of people who could help me be successful in this thing, right? So a habit of a fearless person is saying yes and then showing up. Your yes does so much more to you for you than you could really ever imagine. But the most important thing is to not be reckless, because being fearless for the sake of being fearless means nothing. You have to have a strategy for everything you do. And I think that if you were to ask anyone who has ever crossed my path, my grandparents, my family, my friends, my corporate America coworkers, and my business clients and teammates, I think they would all tell you Sydney is very organized, but it's actually not organization in here. Okay, in my brain, it's like spaghetti, it's jumbled, it's messy. The messy middle is what I like to call that. But I have a strategy for everything I do, because if I let everything in my brain stay this jumbled mess, I'd never be able to actually take action. You see, my strategy is going to look different than your strategy because I'm a different person, but I do want to share with you some of the components of my strategy that have made me very successful. The first and foremost is I always think about the end first. Who is the user? Who am I going to impact? Once I have considered that user, I seek advice from people around me. That could be YouTube. In fact, it's often YouTube, but it's also people from trusted advisors who I know will give me plain, simple feedback and not be scared to kind of put me in my place. I also consider scale. I'm not trying to build something just for myself or just for one instance. How can this thing that I'm creating, what happens when it's 10 times, 100 times as large? So I always consider scale in what I'm doing, which leads me into learning how to build. How do I pour a foundation that is firm so that when I scale, when I build on top of that, I'm successful? And equally as important, I learned to break things. If I can break it, someone else can break it probably faster, right? You see, I don't think that I'm the smartest one in this virtual room. I'm certainly the smartest one in my physical room, because the only other person here is my husband, and boys drool and girls rule, but I'm not the smartest one in this virtual room. However, I'm probably one of the most fearless. And the only reason that's true is because I have no problem saying yes. My yes leads to me learning new things. When I learn new things, I figure out what I like. That is how I got from corporate America, technical career in data science, helping Cheetah build algorithms for a really cool platform, to running a creative business where the majority of my time is spent managing people, doing creative writing, graphic design, and building systems, something totally different than I ever did before. I tried new things and I realized that the thing that I like is learning and leading and communicating and being in relationship with people. So now, instead of having a career where I'm kind of researching by myself, I talk to 20 people a day. That fills my cup. That might not fill yours. But by you showing up fearlessly and saying yes, you're going to learn new things. You're going to fail at things. You're going to realize what you like, realize what you don't like, and take that and move forward. You can either be stuck like I was, very well paid and very undersatisfied, or you can be very well paid and fulfilled. And ultimately, you get to choose. And I want you to remember that you get to make the choices that will leave you feeling fulfilled. Whenever you're feeling unsatisfied, recognizing that you get to change. Just because your friend went to go work for Microsoft so that they could make a wonderful salary, they might be doing something that you don't want to be doing. Maybe you want to work for a startup. Maybe you want to work in manufacturing. You get to choose so that you can feel fulfilled. And I promise you that when you show up in your career and you pursue your career in a way that puts fulfillment first, you're going to be well paid, right? Which is the point of all of us going to college, getting a good job, yada, yada, make our parents happy, be able to sustain our own lifestyle, right? So remember, the key takeaways of this are to show up fearlessly in the pursuit of your career. You need to cultivate a mindset that reminds you that you're the only one in charge of what happens in your career. Remember, I am at cause for my life. I get to control how I respond to everything, and I get to take 100% radical responsibility for my life. Once you have that mindset, you get to support it with habits that help you find and seek the boundaries of your life and your career, and then push them. That's all I have for you guys, but I'd love to answer some questions.
Thank you so much, Sydney. This was exceptional. I'm actually speechless. I'm rarely lost of adjectives, but today I am. This was truly amazing. I made 2 pages of notes while you were speaking, and I can relate with everything that you said so much.
Thank you,
I
Sheila.
definitely do not do everything so nicely, so well organized the way you just mentioned. I do some of them, but when you were speaking, I could at least recognize them, and because now I can recognize them, I can do it even better. Before, I will just do sometimes, otherwise I will not do it because there was no definition attached to it. You helped me define how to do it, so now I can do all of these things much better. And I'll give you one example. I remember when I was coming out of my undergrad school, then like you, I was also looking for jobs. And at that time, I will, in the interviews, when it's the HR round or something like that, they'll ask me, okay, do you have any questions for us? And I will have no questions. They will ask, and I will say yes to anything. Like, there's, are you okay with flexible hours? By that, they did not mean like what flexible hours means now. They meant, are you okay with working 12, 14 hours a day? Are you okay? And what they mean, are you okay coming 2 a.m. in the night? And I will be just, yes, okay for everything. I did not have any say. I did not have any choice. I changed from there to now. Now I look for core values, and that makes me fulfilled, satisfied where I am.
Yeah, for sure.
So much thanks to you, Sydney. Whatever you said, I think it will help all of us over here to better structure ourselves, know our capacities better, and channel our energy at the right places.
For sure.
Thank
and I
you
want
so
to
much,
spend just
Sydney.
30 seconds real quick answering this question in the chat. You said, to be fearless, what if we take a decision fearlessly and it turns out to be wrong? That's the definition of fearless. You learn from it. There is no wrong. There is no failure when you're fearless. There's learning. That's it. If you're stepping forward and you're not making mistakes, you're not taking enough risk. Risk and reward really do go hand in hand. Again, don't be reckless, but you're going to make wrong decisions. You're going to mess up. And the goal from that is to learn from it and move forward. That's a great question. Thank you, Cheetah.
Awesome. Yeah, I didn't know you got a question there. Thank you for answering that as well, Sydney. Thank you again. Thank you for being here.
Yes, absolutely. Thanks, everyone.
All right. We just concluded one of the best talks I've heard so far. We will start our next session in 5 minutes. Let's take a 5-minute break, and we'll be back at 7:05 and 8:35 for the US time. See you all soon.
St. Claret College, situated in North Bangalore of Karnataka state in India, aims to create an informative and sensitive future citizens through Claretian mission of education.
At St. Claret College, the focus of our education is to form individuals of character and integrity. Individuals who would become agents of social change and transformation. And for that to happen, we will certainly provide our students well-rounded education.
Situated on a serene and picturesque campus in the Garden City, Bangalore, we provide world-class state-of-art infrastructure and facilities to our students.
Our graduates become critical thinkers. Our graduate becomes individuals who are really very creative. And that happens when we provide them with an engaging curriculum. A curriculum that certainly responds to the needs of the industry, responding to the needs of the times.
Claret Group of Institutions caters to a large number of students, more than 9,000 in its campus, enabling them to understand and learn together to become thought leaders.
We believe in education that is inclusive and socially just. So Claret College has been offering education at an affordable cost to help and support everyone's aspirations.
Holistic growth of students is the core of our educational mission.
The education that we offer is faith-based Catholic education. And at the same time, we know the term Catholic literally means universal. And our education is inclusive. Our classrooms certainly represent the diversity of culture, diversity of languages, diversity of belief systems that India represents. And we offer our students the best so that they become global citizens.
Welcome to Claret College, the abode of knowledge.
All right, we will start now. All right, so we will resume from where we left yesterday. Yesterday, we were talking about the roots of deep learning. The roots start from what we have in machine learning, such as regression and logistic regression. Yesterday, we also learned about what is a loss function, because the goal whenever we are developing any model is to define a loss function that is our objective, and we try to minimize that loss function to estimate our model. And why are we developing these models or anything? The purpose to develop any model is to learn patterns in the data to predict something that will help you make decisions. We also learned about gradient descent. If you recall, we used a remote car example to understand how gradient descent works. We learned that gradient descent is the way, an iterative way in which you can learn complex models, and we'll talk more about that today. Today, we will jump to deep learning concepts. Primarily, we will learn about the basics, the neural networks. It started from there. More specifically, they are called multi-layer perceptrons. I highly recommend everybody here to make notes on a pen and paper. And also, you can open the textbook link that I sent to you. We will be using and referring to that book quite a bit during this session, and also during the homework, the book will help you. Coming back, the topics that we are going to learn today are neural networks, activation, long and short-term memory networks, also known as LSTMs, and convolutional neural networks. And like yesterday, I won't be spending time on PowerPoint. I will quickly jump on the notebook, the Jupyter notebook or Collab notebook. I'll show you how things work, and then I will come back to the whiteboard and give you the theoretical details. So starting from multi-layer perceptrons. Okay, yeah, sorry, I had to share my notebook. Give me a second. This is a notebook I shared with you a while ago on Telegram. Please refer to it as I'm going through this. In this notebook, what I'm showing you is yesterday, what we were modeling, here's what we were doing yesterday. Yesterday, we were modeling a data in which there's linear dependency. If you look at this plot here, on the horizontal axis is my X and the vertical axis is my Y. And you can see a almost linear relationship between the X and Y. But what if your data does not have a linear relationship like this? This is a non-linearly related data. If you have such a non-linear data and if you're still using a linear model like linear regression, this is what happens. The outcome is this. It tries to fit a linear line, a linear pattern, which definitely does not meet what we are looking for. So we have to find another way to model such a data where nonlinearity exists. To do that, we have developed the basic most deep learning model, which is also called multi-layer perceptrons, and it is made up of dense layers. What is dense layer? We'll talk about it on the whiteboard. The point is, this is the simplest deep learning model. And if you look at its outcome, it could almost model this nonlinear relationship. So basically, the point is, this deep learning model works. Few things that you might note in your in this notebook is we have few things such as activation units and so on. We can go over this when we are on the whiteboard, and if we cannot cover it, then we can take it up if somebody has questions during the Q&A. So we just saw that deep learning can model my nonlinear data. Before we move further and get more attracted to deep learning, and deep learning very easily becomes very selective because deep learning comes with lots of promises. Give it any type of data, the data should be sufficient enough, and you'll be able to model it using deep learning. I've seen people jump directly into deep learning without even thinking once that should they first try something simpler. This is an example to debunk that approach. What I'm showing you here is what I solved using a deep learning network can also be solved using a standard machine learning model called as SVM, support vector machines, in this case, support vector regression. And it worked better than deep learning. And the main learning I want to take away from this is that do not do not jump on deep learning directly. This is also a philosophy I want all the data scientists to really follow, is that you should know the meaning of every type of approach that you have out there. And they come from both machine learning and deep learning. When I have to solve a problem, I usually start with machine learning approaches, because as we discussed yesterday, or no, day before, when we were talking about AI demystified, then we also covered that machine learning is more interpretable. It is also more scalable. Therefore, it is imperative to start with machine learning approaches. That's what I do. Deep learning models, on the other hand, are really good at solving much more complex problems where you cannot have a formula-based machine learning approach to solve it. So deep learning is for them, but for this dummy example problem, your main learning is deep learning can solve it, but machine learning can also solve it. Now, let's move on to another type of modeling. When we have temporal data, what is temporal data? Temporal data are data which has time component in it. And whenever there is a data which has time component in it, you will see repeating patterns, basically cyclical patterns. All of us have heard this common phrase, learn from the past, learn from the history. History has a lot to teach you and so on. Why do they tell these things? They tell history has a lot to teach you because history does have a lot to teach you, because things repeat. What happened in the past can happen again. The patterns in time repeat itself. Stock market modelers, they do this a lot. They always talk about, okay, stock markets follow a cycle. If this cycle has gone too long, then something will repeat and so on. The point is, whenever you have a temporal data meaning data which is in time, you will have repeating patterns. To model repeating patterns, by the way, what I'm going to teach you just now, I will demonstrate it with a dump truck afterwards. So we will have a little more explanation of these things soon. But for now, while we are looking at this chart over here, when we are trying to model a data which has such temporal patterns, we want to have a model which has the ability to learn the past and preserve those learnings. What is the one word for doing this? A one word for learning from the past and preserving it is called memory. We all have our memories. We learn from we keep our memories so that we can use it in the future to make a decision. I'm thinking of a real example on how we use memory in our day-to-day basis. I think we do it for pretty much everything. When you were very young, you would have touched something really hot, a hot cup or a hot pot, and your hand would have hurt. So you preserved a memory that if you touch something which is hot, it will hurt you. So you don't do it anymore. Imagine if your brain could not retain any memory, then every time you see a hot object, you do not know whether to touch it or not. So the point is, keeping memory helps us make better decisions. There is this class of model called recurrent neural networks, also known as RNN. And among this class of neural networks, there is one very popular one called LSTM, or long and short-term memory networks, which we are looking at here, LSTM, which can model such temporal data. The data that I'm demonstrating here is a very straightforward, easy to model data. It has no noise or anything. This is only for demonstrating to you that LSTM can very easily model such temporal data, which I'll show you when I fitted the model that I had earlier, the model which could, the MLP model which could model that nonlinear data. I'll go back and show it to you. The model which could do fine over here did pathetic when it was to model such a temporal data. What it means is that even in deep learning, you do not have one magic wand, you do not have one magical model that you fit to any data and it works. No, you have to become knowledgeable of different types of models you have in deep learning so that you know how to use and when to use what. So the previous model did not work at all here. We will develop our Lstm model. There are some details on how to use an Lstm model. You have to first reformat the data. It is called temporalizing. This is also given in book. You can refer to section 5.4.2 in the book to understand what I mean by temporalizing. For this particular session, I will keep it short by saying it reformats the data so that you can learn. You allow the model to learn from certain windows of the input. So we did that, and you can see the predictions from the Lstm model is pretty much on top of the data, which means you could really model this data very, very well using Lstms. Moving on. One type of data that we find very commonly when we are modeling things is image data. Image data has distinctive patterns in it. And there is another class of model called convolutional neural network, which are exceptional at modeling such type of data. A data where you have to learn patterns. CNNs can do that. Convolutional neural networks do that. For demonstration here, I'm showing you if I have to develop a model where I have to train the model to detect whether an image is letter 2 or not. The inputs look like this. If it doesn't look like this, the model should know it is not 2. Otherwise, it should call it out as 2. I did this. I read the data. I modeled them, and here is my convolutional neural network model, the CNN model. And it worked pretty amazingly. If you see the actual versus predicted, they were 100% match basically. This is a 100% accurate model. And there is no surprise over here because for demonstration, I used the noise-free data. And noise-free data means it becomes easier for CNN to learn the patterns. The main thing that I want you to see here is how nicely CNNs learned the shape patterns. A letter 2 has 2 distinctive patterns in it. Let's see what they are. A letter 2 has a semicircular upper region. The top of the 2 has a semicircular shape. And over here, around the neck, it has an angular line. This example is also very well demonstrated in the Understanding Deep Learning book in chapter 6. Please go and refer to it. Here we are showing that a CNN model could automatically learn these distinctive patterns of a semicircle and an angular line from letter 2 to distinguish. If you give it an image and if it sees these 2 shapes, it will know that it is letter 2. Moreover, it will not be confused if I reverse these sections of the image, and I will try to show you if possible. Give me a second here, please. What I'm trying to do is I will run this part of the code so that you know what I'm saying. So now we are reading the input data, and this is a letter 2 as it should be. And I'll show you another thing. This is a distorted version of it is nothing actually. This is an inscription which was given as another input to try to confuse a CNN model. What confusion it is doing is it also has a semicircle. It also has an angular line, just as letter 2. If a CNN model was to work by only looking for these two patterns, irrespective of whether they are located in the input image, it will recognize both of these two letters as, both of these two inscriptions as letter 2. But a CNN model is smart enough to not confuse between these two. And imagine why this is so important. CNN models are used for recognizing human faces. What distinguishes a human face? 2 eyes, eyebrows, a nose, and your lips, at least at a high level. CNN models understand that it has to look for these 2 eyes, it has to look for eyebrows, nose, and lips. But imagine if CNN models do not care how they are placed to give an image with 1 eye here, lips over here, and so on, all contorted, it will still recognize that as a face, but it does not. And it is important that it should not, because the location is also important of these patterns, and CNNs know how to deal with it. So an important thing that we learned, CNN models are really exceptional at learning such shape patterns in your data, and it also respects the position of those patterns where it has to look for to make your predictions. After this, we have homeworks. So I will leave all of you. I'll just give you a big picture of why I would like you to do all of this homework. When you do this homework, you will see that CNN models are not restricted to be used only on image kind of data. CNN models can be used also on the temporal data, this data that we looked just a little while ago. CNN models work by learning patterns, and it doesn't matter whether it has to learn patterns from image, it can also learn it from such time series data. Apply it on this data and you will see it is working as good as the LSTM was working. This is the output I'm showing, and these are the filters. These filters are the shape basically, which was earlier a semicircle and angle line when we were learning how to detect letter 2. So go and do this CNN exercise, and that way you will appreciate the greatness of CNN the way I do. After that, learn how to develop a dense layer network. This is another exercise that I really like. When I was developing that CNN model for detecting letter 2, I can also develop a ordinary dense layer network to do the same job. But I do not do that. I do not do that. A dense network will work as good as how CNN worked. Even a logistic regression will do as good as how the CNN worked. I do not do that, and that is what I have written. Why I do not do that in this learning? It is because some special characteristics of CNN that comes really handy when you have to develop a scalable solution. Scalable solutions are very important. Sydney was talking about it in her talk just before this session, where she said that when she is solving a problem, scalability is in her mind. You have to see the end, what you have to build towards it by the end, and that should be scalable. CNNs are scalable. These logistic regression or dense layer networks, they are not scalable. Go do this exercise. The why it is not scalable, it is also mentioned in section 6.3 in the Understanding Deep Learning book. You will learn everything that I'm saying here over there. After that, I would like you to do some real data modeling. The data set that you are seeing here, those are simulated data sets which are not available with the notebook. That is okay. You can simulate them yourselves also. I want you to apply all of this on a real data. That is how you will understand how to apply this for real world problems. So go back and apply them on the sheet break data set. Set it up from one of the chapter in the book, and then follow some of the things that is mentioned over here to do some exercises. So that is all about the notebook exercise. And now we will go to whiteboarding and talk about the theory of what we just learned over here. Apparently I became mute. Can you hear me? And I just got a question from Nancy. Nancy, the PDF is already shared on the Telegram. There's a link given to you. Please go ahead and download the PDF from there. Okay, so I'll come back to the concept of deep learning. Yesterday, we were learning basic regression, our expression for regression. What we were doing yesterday is imagine this model as a box. This box gets your input of x's. All these x1, x2, x3 make your whole X matrix. Here you perform some operation which is equal to x beta to give you the prediction of your response y hat. What happens when your things become more complex? This is a unimodal decision maker. What is unimodal? Remember the example that we were talking about when we were having the first session on AI Demystified. What we learned there is, some of you might recall, we had an example that one formula-based pattern recognition that was done by Newton is force equal to mass times acceleration. You can see and feel this formula. But if you are doing something in your real life, like I throw a ball to you, the ball is following a trajectory and it reaches here where you are standing, you catch the ball without even knowing how you know where the ball is going to land. What your neural networks in your brain did is broke down this complex problem of this trajectory path into much smaller subproblems, such as it looked for what was the speed of the ball, what was the direction of the ball, what was the wind speed at the time, and so many other smaller parts of the problem, solved them separately, and your brain put all of those outputs of those separate problem solving into one to ultimately tell you that the ball is going to land over here. That is how a neural network works. A neural network is a combination of several models. Your X doesn't just go to one of your box, it will go everywhere. Now your X is going to all of these boxes. The outputs of these boxes will go into another box because you have to, of course, summarize everything to get one final output. To give you your final prediction. This is the beauty of neural network structure. It is going to deconstruct your complex problem into the smaller sub-problems, put them together, and give you your final prediction. I just put some superscript on these betas to distinguish what I'm trying to say here, that these weights actually, in deep learning terminology, people change the beta to another variable. It is more commonly known as weights, W. And I don't want to get into why people use different terminologies for the same thing. Some of it comes because different type of people are solving different type of problems. This beta expression is more common in the statistics world, where regression started. This weight W is more common in the computer science world, where deep learning started. So this is all about the field that from where things are coming from, but they are all the same thing. Coming back, this is how your model is deconstructing a complex problem into smaller sub-problems. And there's one other important thing happening. Activation. If you are even a little bit familiar with any deep learning modeling, you would have heard of activation functions. Activation functions are applied at the output of each of these. So suppose this is denoted as F. Before letting your output reach the next level, you apply a nonlinear activation function to it. Why do we do that? We do that because let me first tell you the intuitive reason, and then I'll tell you the mathematical reason. The intuitive reason is that imagine how our brain works. The neurons, by the way, from where all of these things have been inspired, the neurons, each of these things is like a neuron. When your neuron intercepts any input, any information, it emits an output. And it emits an output in the form of a simple pulse. That pulse is like this. It is a simple signal. It is not it is not a continuous number. It is just a binary-like pulse. Same thing we try to emulate here. And it is really important that we do that, because if we do not apply these nonlinear activation function, no matter how big, how many layers I put here in my neural network, all of this is effectively equal to a standard linear regression model. I'll say this again. If I do not have these activation F functions, without that, this entire thing is effectively a simple linear regression model. Why? Because these are simply X times this, and then that goes to here. You multiply it again with, I'm just giving you a loose hand, high level explanation. The explanation is in one of the appendices of the UDL book. So you can go and refer there. But the short answer is, in this process, what we are doing is matrix multiplication or dot product of this output with this, and you'll see what happens. I can replace this with another weight matrix, which ultimately gives me how a regression function looks like. So what we are learning here is, if you do not use this nonlinear function, all of your matrix, this might not be exactly right. I do not recall the exact way in which this all comes together. But regardless, the point is, these weights that you have over here, all of them get squeezed into one large matrix, which is the same thing as what you would have learned from linear regression. That tells me the basic construction of a neural network, of a deep learning network, is you have multiple computation nodes. They act as your neurons. Some computation happen over here. They are passed through a nonlinear activation. The importance of nonlinear activation is that you are able to deconstruct a complex problem into a smaller problem. If you do not use these activations, then your solution is simply a linear regression. We are doing no deconstruction. That's why we have activation. And all of these get together to give you a final answer for a complex problem, and most of the time they're really, really accurate. With this, we learned the first topic for today that we have, neural networks and activation. We will take a few minutes break, and when we are back, we will talk more about how these models are learned. We'll talk about the memory network, which is long and short-term networks, which can preserve memory. And we will also learn about convolutional neural networks. We will use some objects when we come back to have a better understanding of the intuition behind all of these concepts. So right now it is 8:41, I think, India time. 7:41, sorry, 7:41. So let's come back in 5 minutes at 7:46. And for US people, we will come back at 9:16. See you soon. Okay, we are back. Next, what we are going to learn is about LSTMs. If you recall from the notebook, what we are doing is, if we have a temporal data which we denoted like this, a data which has time to it, time meaning this axis is time. Well, as time passes, you are collecting a data, and whenever you are collecting a data which has time in it, you will naturally have some temporal patterns, meaning patterns which repeat. As I said earlier, whenever things are in time, you have to learn from the history, and to learn from the history, you have to preserve the memory from the history. How to make a model do that? How to make a model learn from past? This is done using an Lstm network. What Lstm network does is, it traverses through this timeline. So you can think of it as a memory lane. Again, this is also visually illustrated in one of the images in chapter 5 of the UDL book. Please refer to it. That is what we are showing here using a real dump truck. Imagine this as your timeline or your memory track. What your Lstm model will do is, it will drive through this memory lane. And as it is driving through this memory lane, these are the information it is looking at. Let's say it is A, B, C, and D. When it is looking at these information A, B, C, and D, it will have to interpret which of this information is relevant. If it is relevant, it will keep it. It will preserve it in its memory. And there's another element, another intelligence in preserving memory is, you should also forget irrelevant memory. Think about yourself as well. You do not remember everything. You do not remember all of your past experiences. The mind, the brain, is intelligent enough to filter the relevant memories from irrelevant memories, and it puts the irrelevant memory into the forget category, which means it just forgets it. If you do not forget some of the memory, you will not be able to properly use the memory you are preserving. Therefore, preserving and forgetting should happen side by side to make the best use of your intelligence. That is what LSTMs are capable of doing. Suppose these were my information along the history. LSTM will go through this history, and suppose it determines that this information in A is relevant, it will load it up. It will preserve it. Then it will go to the next station. Here it has found B. Now it will do few things here, few intelligent things. It will see whether keeping the memory of B is relevant in presence of memory A. It will also see whether, if we have to bring B, whether A is still relevant or not. Suppose in this example, the Lstm network learns that B has some extra information that it needs to preserve that is not present in A, so it will keep both A and B with itself and move on. It comes to C, it might realize that in presence of C, I do not need A anymore. It will forget A and dump it out. It will take up C, move on. It comes to D, and it might see that, okay, because I have C and B already, I do not need D at all. So it will not even bother to preserve the memory of D. It will just move on and it will work fine in making predictions. So what we learned here about LSTM will preserve memory and also forget what is needed. Remember this. It not only keeps the memory, it also forgets it because it is able to do both of these, it can very efficiently keep what is relevant, throw away what is irrelevant to make pretty precise predictions. When LSTM came, it quickly changed the landscape and many of the language models that were built early on. Languages have these temporal patterns because as I'm speaking, the sequence of my words together make a meaning. If you listen to my words at random, spread around, it will not make any meaning. So when I'm speaking, the sentences, the order of words in the sentence make it meaningful. And that is why language models are better built using LSTMs. LSTMs are also used for other language models like translations. If you have to translate something from English to Hindi or Hindi to English, you can use LSTMs. It does very well for such sequential data which we have in language. LSTM, in short, did revolutionize these language models. It also made a significant impact on speech models, speech recognition models. Things such as what we use these days, the Siri in iPhones or Alexa on Amazon devices, or Google's. These speech AIs, they also rely to a good extent on LSTM models as well, because speech is also a temporal data like this one. So in short, LSTM is capable of preserving memory and also forgetting unnecessary things, and it is very useful for sequential data such as language models or speech translations. Now we move on to the workhorse of deep learning. Let's release the dump truck. And now I will have something, my next prop, which is much simpler. It's a simple cardboard cutout, but it is the most powerful of all. I had dump truck. I had this toy car yesterday, a dump truck. Now both look very fancy. Not so fancy, but most powerful. This is what I'm showing with this one is there's a pattern in here. And this is what CNN does. If you recall the example we just saw, to learn a letter to distinguish letter to, CNNs learn the pattern of a semicircle and an angular line. This is how CNNs work. CNN works by finding distinctive patterns in an object and uses it for making predictions. The way CNN work is as follows. Suppose this whiteboard is an image. And in this image, you have to know whether this image contains a triangle or not. To determine, and suppose I take a picture of this image and feed it into a model, and the job of the model is to tell me whether this image contains a triangle or not. When I tell you how CNN does it, it will seem extremely obvious to you that this should not be any other way to do it. Unfortunately, things that are so obvious are not so obvious to code into a machine. Therefore, it was not always done as it is now done with CNNs. The traditional approach of solving a problem like this one is you feed such a big image into like a normal dense layer network, which is equivalent to a logistic regression model. So let's talk about how we could have solved this problem using a logistic regression model. In logistic regression model, we would have sent an image which is this big. The size of this board is 4 feet by 3 feet, which will convert to a few million, maybe, yeah, it will be a few million pixels. Now, when I put this on an, let me not get into million or thousand or billion, but it will be several 100,000 of pixels in the image that I will take for this particular board. And when I put it in a logistic regression model, my input X has, let's say, 100,000 pixels in it, which means the beta or weight that I have to learn for that logistic regression model will have 100,000 parameters in it. That is a lot. That is a lot, many things to learn just to detect a triangle in. It is waste of computation and also very inefficient because you cannot scale that model. But let's see what a CNN does. CNN will not care to learn a weight a weight matrix which will cover this entire image. It will learn a set of weights which is as big as the size of this filter. This will be like few hundred, like a fraction of what was over here. And what it will do is, it will take this filter and run it across the whole image like this. It will sweep the whole image. And while it is sweeping, it will see that it found a match somewhere. And then it will call it out as, yes, a triangle was found in the image. If it was not a triangle, if it was something not triangle, this filter does not filter it completely. It will say a triangle does not exist. What just happened with convolutional network? Quite a few things happened. We learned to detect a triangle with a weak filter. What is a weak filter? A weak filter means okay, let's start from what is a strong filter. A strong filter is what we would have learned in logistic regression. We would have learned a weight matrix which is as big as this my entire whiteboard. A filter which is as big as this my entire whiteboard. That will be a strong filter because it is trying to fit everything. That is a bad thing. It is not scalable. CNN learned a weak filter which is a fraction of size of this whiteboard, and it is still doing its job. CNNs work by learning multiple weak filters and put them together to get to the final solution. That is what it did when it was learning the letter 2. When it was learning to detect letter 2, it understood. I try to make it 2-dimensional. The best I can do. So to learn a letter 2, it learned 2 filters. One filter was a semicircle, and the other filter was an angular line, almost like this. It knows that, and now these 2 filters are really small. You can see that these 2 filters are a fraction of the size of the entire image. It will look for presence of these 2 patterns in the image separately, and then it will put them together. If it finds this one and this one, along with another constraint that this should be at the top, this should be at the bottom. That means you have letter 2 in the image. What it did, it used bunch of weak filters to make a decision. What we did, again, is deconstruct a complex problem into smaller sub-problems and then solve it. This is the smartest way to solve a problem. Divide a complex problem into smaller sub-problems, weak filters in the case of convolutional neural networks to get to the solution. There are some other properties of convolutional neural networks as well, such as parameter sharing, equivalence. I would like you to go and learn them. It's very well described in the UDL book. The property of parameter sharing, I can give a quick brief. What it means is, when we are learning these, suppose we are doing logistic regression, we are learning this entire filter. In there, we are not sharing the parameters. Suppose I, in addition to letter 2, I also had to detect letter 0. What is common between letter 2 and letter 0? Letter 0 also has a similar semicircular pattern to it. Which means that if in my problem I have to detect both letter 2 and letter 0, I can use the same filter. So with the same filter, now I will be able to filter down 2 letters. I could share the parameters. This makes my model even better. I can learn with fewer parameters solving more complex problems. This is the extreme power of convolutional neural networks. I will not get into the equivalence property of convolutional neural networks today, because then it leads to a challenge to CNNs, which is solved using pooling layers, and we will not cover pooling today. So I will leave it to you to go and read about them. I'll summarize this, and then we will go back here and briefly talk about how we learn these models using a backpropagation method or backpropagation based method, which is related to a gradient descent. In summary, so far we learned 3 things. We started with learning what neural networks are. The basic most neural network is made up of dense layers, which is equivalent to what we are seeing here. The common underlying theory behind all models in neural network is that it deconstructs a complex problem into smaller subproblems. A nonlinear activation function like f is essential for this deconstruction, otherwise it becomes same as regular linear regression. A dense layer network, like we saw in the notebook, cannot handle our temporal data, which we can handle using LSTMs. And for data which has patterns like image data, we use CNNs. CNNs, which use weak filters like this to learn to distinguish or identify objects in an image. Now, let's move on to how to learn such models. We can go too much detail when we are talking about how to learn deep learning models, because these are complex, otherwise assumed to be a complex model. And when you look at how to get to its solution, you will see some derivative signs and so on, and it appears that it is complex. But the reality is it is not complex. I'll tell you one secret. All good methods, all algorithms which has stayed and which is used today, all these algorithms, no matter how many delta x by delta y by delta x or summations or products or logs you see, end of the day, the algorithm comes down to simple addition, subtraction, multiplication, and division operations. That is the beauty of defining algorithms. So do not be scared when you see derivative or something. All of those are just to write it simply so that one who is implementing it knows what they have to do. So coming to how we estimate these models, recall what we learned yesterday, gradient descent. Another words get added to this when we are talking here, which is stochastic. Stochastic is a fancy word for something very simple. It just means random. First, let me remind you what was going on in gradient descent, and I'll talk about what is the stochastic part. In gradient descent, what we were doing is we initialize our coefficients. We were calling it beta yesterday. I'll just, for sake of consistency, I'll call it W, what I've written here. So we will initialize W with something random. And then I will iteratively update this W as a previous W minus the derivative of the loss function with the weight itself. What is stochastic? The stochastic part is, I'll just write the expression for this one so that it's easier to see. This one is equal to you see we have this part comes from the data. Suppose you have n observations. In stochastic descent, what you do is you do not use all the n observations together when you are learning the W matrix. You use a random subsample of it. This is also called batch size. If you are familiar with deep learning, why we do this? We do this because of two purposes. One is efficiency. Data sizes are usually very large. If you're fitting all the data together, computation becomes too high. And it can be shown mathematically that the answer that you get by randomly subsampling data and then estimating is close to, if not equal to, what you will get if you put all the data together. It's mathematically proven, so I believe in it. The other reason is when you do it stochastic, like when you take a random sample at a time, you are more guaranteed to converge to not the local minima, but the global minima, as opposed to if you are doing it by putting all the samples together. If you put all the samples together, it is possible that you get stuck in a local minimum. So significant benefit of going stochastic, not using all the data at once, it really helps you. I'll just tell one more thing and then we will conclude today's session. We learned gradient descent yesterday. Now we understand what is stochastic gradient descent. It just means that we do not use all the data at once, we use in pieces. Lastly, the method that is used for estimating weights in my neural network is called, it's stochastic gradient descent, where the gradients are computed using a method called back propagation. Backpropagation is the method that was developed in the 1985-86 approximately, which changed the whole landscape of deep learning. This is what I was referring to yesterday. I was telling that due to gradient descent, we could have deep learning models today. And what I actually meant was, with this gradient descent and backpropagation are very tied to each other. Backpropagation gives you the gradients of different layers of a deep learning model. And using those gradients, because you need these gradients, you can use the stochastic gradient descent method to solve your problem, to estimate your model parameters. What happens in backpropagation is, suppose if you are trying to find the weights at this layer, you will have a chain of let me get some space. Now, instead of having a gradient which will be as simple as differentiating your loss function, the loss function which will be here at this stage. Remember what loss function is. It is simply summation of, if I'm talking about ordinary least squares loss function or MAC loss function, it will be binary cross entropy, the equivalent of that. That's not important. The main part is the loss function is some kind of difference between your prediction and actual. When you are doing backpropagation, you have to differentiate for each layer as you go backward for each layer of your model. And yeah, this one I should correct. This one is f of the main point that I'm trying to tell you here is the gradients, the expression of gradients just keep on expanding if you have more layers in the deep learning network. This will start with the first derivative with the loss function with the weight which is closest to the end. Then as you go down the layers, this expression continues to expand. And the problem with that is, if you have too many layers, you can see there is a product of gradients. Products, what is the problem with product? Products can get small very quickly if these elements are small, or they can explode very quickly if these elements are large. These problems are called gradient vanishment. When you keep on multiplying small number, it quickly becomes close to zero, which means it becomes impossible to learn your weights. If you are multiplying large numbers, things explode very quickly, you still cannot learn your weights. So that was a challenge of gradient vanishment and gradient explosion that also came when we had the backpropagation implemented for estimating our models, which was later resolved by some new research and advancement in the activation function, and also using batch normalization approach that helped us prevent the gradient explosion. Another thing, these notations are loosely written, including over here. The exact mathematical notations you will find in the UDL book. This entire illustration will help you to understand the high-level concept. With that, I will conclude today's session, and we can start taking questions.
Thank you so much, Dr. Ranjan. This session was really insightful. You have deconstructed and simplified such a complex topic for all of us. I'm sure the audiences are awed by your explanation. I myself was indeed, I was following everything that you were trying to explain. So with that, we do have a few questions from the audiences. First question is this is from Professor N.M. Khandelwal. The question goes as, for analysis of curvilinear temporal data, which method will be used? Please show the formula as well.
So I was just trying to write it down so I remember. So the question is to model a curvilinear data. Is that correct, Pansi?
Right. So I'll repeat the question. For analysis of curvilinear temporal data, which method will be used? Please show the formula as well.
For curvilinear data, for curvilinear temporal data, I start with some of the machine learning tools, and then I move on to deep learning tools. I usually start with modeling it using the Fourier transform. With Fourier transform, I can easily include several frequencies while I'm modeling the data. In Fourier transform, basically you have the sine and cosines so that you can easily put different frequencies of the data. After that, I use LSTMs. I showed the LSTM is used for temporal data, specifically curvilinear temporal data can be modeled with LSTMs. And CNN. CNN is something I find works pretty well for all such types of data. It's a one-stop shop for most of the problems that we have. So if I were you, I will start with simple machine learning approach. In that machine learning approach, I will include the features of Fourier transform. After that, I will try this LSTM followed by CNN. And depending on your needs, if you are looking for things to be more interpretive, you can just stay with the Fourier transform modeling.
Thank you, Dr. Ranjan, for that answer. We have another question. The question is, why we use activation function?
Glad it was asked again. So I was explaining it earlier. What will happen if we do not use an activation function? It might get me to actually write it down, what I'm trying to say here. If you have the PDF of the Understanding Deep Learning book open with you, open Appendix A, if it is in page 369. That is very clearly showing what happens if you do not use an activation function. Not using an activation function is equivalent to using a linear activation function. What is a linear activation function? It is nothing. Basically, the input is equal to output. So when you do not use an activation function, what effectively happens, and I am looking up that appendix of my book, your ultimate prediction y hat becomes equal to just won't try it anymore. Triple transpose. So what is happening here? Yeah, now I can explain to you what is happening here. So the output of this is, suppose Z. Suppose this is equal to Z. And I'm not putting it through an activation function. say I'm passing the Z directly over here. What I'm effectively doing is, to get to my output, I'm doing this is equal to my original X, and this I can write this is simply a matrix multiplication. So I can put them together as one large matrix. So effectively it becomes equal to W times X, which is same as the linear regression expression. So what it means is, if you are not using activation, your large model is effectively a linear regression model, at least when it is a dense layer. And what is worse? The worst part is, if you are not using activation here, due to this, you are not able to deconstruct your complex problem into arbitrary subproblems. As a result, you won't be able to solve a complex nonlinear problem. Now, I will also say this is not using activation or keeping activation as linear. It is not that you should never do it. You can do it. You can have activation as linear in a convolutional neural network. Convolutional neural network learns a filter. When it is learning a filter to sweep an image to look for patterns, it has already deconstructed a complex problem into a smaller subproblem. You do not rely on an activation anymore to deconstruct the problem for you. Point is, for convolutional neural network, you can use linear activation. It is completely fine. In fact, if you look at one of the sections in chapter 6 of the book, it is telling you to use linear activation for the output of convolutional neural network before using pooling. Because if you do not do that, if you use a nonlinear activation, it distorts the distribution of convolution output. In simple words, you are distorting the whole network. You will do better if you are using linear activation on convolution, then use pooling, and then use nonlinear activation. That will work better than if you directly use a nonlinear activation on a convolution layer. So in traditional dense layer network, nonlinear activation is essential. For CNNs, not so much. It has already deconstructed the problem. For LSTMs are constructed differently. LSTM, we call it as a cell. So every node of an LSTM is a cell, and it's a complex cell. Within that cell, you have 4 different types of gate. What is a gate? Gate is simply you are allowed to get in or not get in. If you are getting in, your memory is preserved. If you're not getting in, your memory is not preserved. Sometimes you're also thrown out of the gate, which means the memory was forgotten. For those gates, a very specific type of activation is essential, which is tanh and sigmoid, based on which type of gate you are talking about. And you have to stick to those activations because they have certain properties that enables this memory preservation or forgetting. So activation is essential in most of the things, not in some of the things. But the short story is, yes, activation is essential.
Thank you for that explanation, Dr. Ranjan. The questions are pouring in. So the next one is, ideally, for how many epochs should we train the model? This is by Dr. Nazura Javed.
Very good question, Dr. Nazura. But I can just tell you what I do, because there's no right or wrong answer to this. When I am starting with prototyping, I train the model for only few epochs. And when few, I mean like 5 or 10 epochs, because I just need to see whether I do a sanity check on everything. What I built, does it make sense or not? Is it doing what I'm trying to do here or not? I do not start modeling by running it for too many epochs, only to know after 100 epochs that it did not go anywhere, or I made a mistake. So I start with only training it for a few epochs. After that, there's no, again, right or wrong, but my general rule of thumb is to run things for 100 epochs. But if the modeling is more complex, I sometimes keep it even fewer epochs. One other practice I follow is that in TensorFlow, you can start retraining the model from where you left, even after your program has ended execution. Meaning, when I do my model.fit, and suppose I have run it for 100 epochs and it reached certain level, I can again run that code, that only the fit part, and it will start from where it left. So I do not have to try for a very, very long epoch from get-go. I can go in stages, see at different stage how far I reached, and then start from there. So because resuming fitting is very straightforward in TensorFlow, it's really not that much of an issue, even if you start with a small number of epochs.
Thank you again, Dr. Ranjan. I hope, Dr. Nazura, this answers your question. There is another question, Dr. Ranjan. This is, what is black box? Why deep learning has the lack of transparency?
No, it's not deep learning to blame for its lack of transparency. We are building that. And let's go back to what we were talking a couple of days ago when we were demystifying AI. We said AI came from how our brain works. Our brain works by intuitively breaking down complex problem into solution and then getting to an answer. And going back to that problem of throwing and catching a ball, how do you know you have to extend your hand here? That ball is coming to drop exactly here. You do not know that. You do it subconsciously. That is how brain works. And that is how deep learning was developed at the beginning, to emulate how humans think. So it is not that deep learning chose itself to become a black box. We built it like that. It's us, the creators. And now there is significant amount of work that is going in to make deep learning explainable, because now we are learning more. It's again an iterative research. Some of the things that we do, we can explain them. Humans can explain why I do certain activities. We are trying to emulate that in deep learning models as well, to make deep learning not a black box, explainable. In fact, Dr. Shubhaji Das, who was with me yesterday, he said that he was working with DARPA, the Defense and Research Organization in the US, for explainable AI. There's one other company of one of my friend. They are working with another defense organization in the US. They are also working on making AI explainable. So basically taking out this black box aspect of it and trying to make it explainable. To answer in short, we are still at the early stage of all of these development. We will keep progressing, and some part of the black box is by design. It is necessary. That makes it more efficient. But we are trying to unravel the secrets by unboxing as much things as possible.
Hopefully that covers it. Let's move on to the next question, Dr. Ranjan. How we assign values to the weights? Are there any specific methods? This is by Rennie Jose.
Right. So if you mean how we initialize the weights, initializing the weights, there are some standard ways to do that. I said that we do random initialization. The most common way of initializing is we're using a method called you're not uniform. In a very simple word, what it means is, if you have to initialize 100 weights, you uniformly randomly choose a number between 0 to 1, 100 numbers between 0 to 1 or -1 to 1, and you put, yeah, it is rather -1 to 1, and you assign to these weights. Why we can randomly assign weights between a certain bounded, like between -1 to 1, and why don't we need to go beyond that, is because of one very important thing we do when we are fitting any deep learning model is scaling. We scale the input data. You can go back and see the exercise from yesterday. In yesterday's exercise, I was showing the importance of scaling the data before we put it into a gradient descent estimation approach, which all the deep learning models use as well, as we see here. Whenever we are using any gradient descent based method, we must scale the input data, because otherwise the gradient either vanish or explode. And because we have all of my input x's scaled, what scales means is if your original x1, x2 are in completely different ranges, like one is in 1 to 100, the other one is in like millions, after this scale, both of them will have the same distribution, like it will be between 0 to 1 for both of them. Now, because you have scaled all of your data, now you are okay with randomly initializing the weights in the same range for all of them, because the effects, the cause and effects are going to remain the same.
Thank you, Dr. Ranjan, once again. We have another question. Are the number of filters used in CNN dependent on the features to be detected? That is again by Dr. Nazura Javed.
Yes, Dr. Nazura, that is correct to some extent, definitely. If we have an a priori knowledge of how many shapes we are looking for in an object, how many pattern shape we are looking at an object, we can define the number of filters ourselves. That is true. In practical problems, it is sometimes not possible to know a priori how many shapes we should be looking for. Even a simple problem like letter detection, 0 to 9, through images, because people write letters in so many different ways, different handwritings are so different, that knowing a priori how many shapes you are looking for is challenging. It serves well if you know it, but if you don't know it, you start with your best estimate, and it is better to start with a larger number of filters than you think you should be putting, and then applying some type of regularization. There are different ways in which we can put regularization, but the whole point of regularization is if you are having a bigger model than you need, you have too many parameters to estimate, and that becomes a challenge. To resolve that problem, you can do regularization, which will help you automatically weed out the unnecessary extra parameters to still able to learn your model. It's always good to use an a priori knowledge. If you cannot, then just have a big model and do regularization of some kind.
Thank you, Dr. Ranjan, for the great explanation. We have one more question. Is it possible to diagnose and predict cancer cells using CNN?
I'm not expert in this field, but I know people who are doing it. Because I'm not expert of cancer cell detection, so I cannot answer any better than that.
That's all right. Thank you so much, Dr. Ranjan, for your time today and for such a wonderful session. It was really insightful. And with that, we conclude our day 3 of the AI Workshop 2021. The link to tomorrow's session will be posted in the chat. You will also get an email with all the details and the material required for tomorrow's workshop. See you all tomorrow. Thank you so much for attending. Thank you all.
Thank you. Thank you.